This is Unit 12, Lesson 4, Part 2. So we're going to finish up our work with the unit circle, get into some more details here. So at the top of the second page, we are looking at signs of the trig functions. So I mentioned to you guys that now that we're working in the entire coordinate system, sine and cosine and tangent can be either positive or negative. Because if we're working with values that are over here, they're all positive, right? Because we're in the first quadrant, x is positive there, y is positive there. But as we move over into the second quadrant, third quadrant, fourth quadrant, you're looking at these ordered pairs connecting back to cosine and sine. And if ordered pairs can be positive or negative, then by that definition, cosine and sine can either be positive or negative. And tangent is y divided by x, so tangent would also, therefore, be able to be negative, depending on what quadrant we're in. So, quick little reminder. If you are sitting somewhere in the coordinate system, our ordered pairs are positive and positive when you're in the first quadrant, negative and positive in the second, negative and negative in the third, and positive and negative in the fourth. So if we are in the first quadrant, everything is positive. So cosine's positive, sine's positive, and the division would also be positive. So everything, all three of them, are positive in the first quadrant. When you move into the second, cosine would be negative, sine would be positive, and so that means the division between the two would come back negative. So the only one that's positive is the y-coordinate, which would be sine. Third quadrant, cosine is negative, sine is negative, so the division between the two would actually come back positive because it's a negative divided by a negative. So in quadrant 3, tangent actually comes back positive, but the other two are negative. And finally, in the fourth quadrant, cosine is positive, sine is negative, so the division would be negative. So cosine is the only positive one in the fourth quadrant. So there's a little mnemonic device. So all, sine, tangent, and cosine for quadrants 1, 2, 3, and 4, we use ASTC, and we use a little mnemonic device. All students take calculus. If you want to say college algebra instead, but this is just like the, commonly accepted one, kind of like PEMDAS is please excuse my dear Aunt Sally. So the kind of generally known one is all students take calculus to help us remember these signs. So let's take those ideas, expand them a little bit into these 4 problems down here. So number 1, if you know, so kind of like going into it, if you know that tangent is going to be positive, which of the quadrants could the terminal side of theta lie? So if tangent's positive, that would be this category or this category. So here, all of them, that means sine, cosine, and tangent, and then just tangent. So the answer here would be either quadrants 1 or 3. Number 2, if you know that secant is negative, which quadrants could the terminal side of theta lie? So remember, secant is the reciprocal of cosine. So 1 is obviously just a positive 1. So that means if cosine is positive or negative, then secant will be positive or negative. So where would it be negative? Not here. Must be here and here, because if they say that it's not positive, that means it's negative. So if only sine is positive, that means cosine is negative. If only tangent is positive, that means cosine is negative. So quadrant 2 and quadrant 3. Cosine would be negative, which would make secant negative. Number 3, if sine is positive, which quadrant could the terminal side lie? So if sine is positive, that would be quadrant 1 and quadrant 2, not 3 or 4. And finally, number 4, kind of a double here. If you know that cosine's negative and you know that cotangent is positive. So cotangent is the reciprocal of tangent. So you're basically asking cosine's negative and tangent's positive. So cosine is negative in quadrant 2 and quadrant 3. Tangent is positive in quadrant 3 and 1, but we already kind of narrowed ourselves down to 2 and 3. So this would just be quadrant 3, where both of those two things are happening at the same time. All right, so let's finally start to expand the rest of our unit circle. So these guys right here, if we are looking at this bottom one right here, we're going to start by filling this in. So this is a summary of what we just did on the previous page. So in quadrants 1, everything is positive. All 3 of them are positive. So all, and then students, which means sine is positive. Take, which means tangent is positive. Calculus means cosine is positive. Those are the positive ones. We mentioned the positive ones kind of assuming that that means the rest of them are negative. So sine is negative in quadrants 3 and 4. That's because y is negative in those quadrants. cosine is negative in 2 and 3. That's because x is negative in those quadrants. And tangent is negative in 2 and 4. That's because one or the other, but not both, would be negative. Okay, because this division is what gives you this sign. This division gives you this division gives you this. So that's a summary of the signs. Now we are going to use that to carry us all the way around the unit circle, and I will teach you how to fill in the rest of these values. So these three numbers, these three ordered pairs, are all you need to transfer all the way around the unit circle. So if you look, for instance, at 60 degrees, and then the next one that we don't know, which is 120 degrees, these 2 points are perfectly symmetric. If you kind of filled in the rest of the coordinate system, you can see they have the exact same y value. So these two have the exact same y value. So if this is root 3 over 2, then this is root 3 over 2 for the y value. And you could kind of move your way down. You can see the exact same thing. Like these two have the same y coordinate. So you can copy this guy's y coordinate right here. And the third one, 30 and 150, have the exact same y coordinate. So you've got 1/2 here and 1/2 here. So this means that these two pairs, like these two sets of angles, have the exact same sign. So like if you were to plug in sine of 60 and sine of 120 into your calculator, you would get the exact same number for these two values. Same thing with sine of 45 and sine of 135, sine of 30 and sine of 150. They are the exact same number. So I can prove that to you. Let me show you just by plugging into Desmos here. I'm going to pull Desmos open on my phone. Always make sure whenever we work with Desmos that we are working in degrees. It'll reset every single time you use the app. So we can plug in the sine of 30. That gives you a positive 1/2. And then you can also do the sine of 150, which gives you a positive 1/2. So they do have the same value. Here's one trick that we'll talk about a little bit more in the next lesson. But if you do inverse sine and you use 0.5, your calculator only gives you one of the answers. So this is something we'll deal with more in the next section. But it's very important to note that inverse sine will only automatically give you one answer, even though there are two different angles that have the same value of sine. It only just automatically gives you the first quadrant answer. All right, so now let's look at these 2 points in relation to their x-coordinate. This is a positive x-coordinate right here, but this is symmetric. So it's the same value, it's just a negative number because it goes over to the left. So if this is positive 1/2 for x, half a unit to the right, this is half a unit to the left. So this would be a negative 1/2. And you can use that same pattern for these. Positive root 2 over 2, negative root 2 over 2. Positive root 3 over 2, negative root 3 over 2. Because all these values on the left have a cosine that's negative, which we mentioned right here when we were talking about the second quadrant. So this, let's use 1/2 just as an easy value. So I will prove these to you as well. So according to this, cosine of 60 is 1/2. Cosine of 120 is a negative 1/2. So watch what happens if I plug those into Desmos. So the cosine of 60 is 1/2. The cosine of 120 is negative 1/2. So it actually is very, very possible that we have negative values for sine, cosine, and tangent. Okay, so now I'm assuming you could guess. We start transferring these all the way around the unit circle. So now like these points in the fourth quadrant, these 2 points right here have the same x-coordinate. So same x-coordinate would be root 3 over 2. Then these two have the same x-coordinate. So that would be root 2 over 2. And this point have the same x-coordinate. So that would be 1/2 for this. So one last little proof for you. Cosine of 330 degrees, whoops, sorry, I did not mean 330, I meant 300, is 0.5. So also 1/2 shares the exact same cosine. And this y value and this y value are opposites. This is half a unit up, this is half a unit down. So this would be a negative 1/2 for y. This would be a negative root 2 over 2. And this one would be a negative root 3 over 2. And finally, our third quadrant still shares that exact same symmetry, except in our third quadrant, the y values and the x values are both negative. So keep that same symmetry, except they are both going to be negative. So same values here, but this time we have the negative 1/2 that we can share with this one, and we have the negative root 3 over 2 that we can share with this one. So negative 1/2 for x, negative root 3 over 2 for y. This one, same y coordinate as this point, same x coordinate as this point. So negative root 2 over 2, negative root 2 over 2. And for this point, same y coordinate as this value, same x coordinate as this value. So negative root 3 over 2 for x, negative 1/2 for y. So that is our entire unit circle. We have every little bit of it filled out now. We're going to be using this a lot. The last thing I want to talk about is this little piece right here. So this, in theory, I could ask you for any of these values, and you should be able to fill those in, not just by looking at your unit circle. Okay, so we will walk through number 5. So find the measure of the reference angle. Remember finding reference angles. We look, so like 150 is right over here. That's 30 degrees off of 180. So the reference angle is 30 degrees. So that's step 1, is you figure out what is your reference angle. Step 2, identify the trig function for the reference angle. So we want to find sine of 30 degrees. Okay, so sine of 30 degrees. You guys had all of these values filled out on this previous page. Sine of 30 degrees is 1/2. Okay, so we know it's 1/2. And then adjust the sine if needed. What that means is this actual angle, the 150, is in the second quadrant, and you're being asked for sine. In the second quadrant, sine is still positive. So when they say if needed, that means if it's supposed to be positive, you just leave it positive. All right, so that is 1/2. Let's move over. We'll kind of do the odds as we move through here. So this one, cosine of 225 degrees. So 225 degrees, here's 90, 180, 225 is halfway through this third quadrant. The reference angle goes back to the x-axis. The reference angle is 45 degrees. Okay, so then identify the trig function for the reference angle. The reference angle is 45. The cosine of 45 is the square root of 2 over 2. In step 3, adjust the sign if needed. We are in the third quadrant. We're dealing with cosine. In the third quadrant, cosine is negative, which means the cosine of 225 degrees is negative root 2 over 2. All right, so I'm going to teach you guys a little trick to memorizing some of these values right here, just so we can have them a little bit easier rather than continuing to reference this chart. So when we are in the first quadrant right here, we're going to do a little interactive lesson. So I want you guys to all take your left hand, so I'll put mine on the screen here. So left hand with your palm facing up. You can kind of imagine that this, your pinky would be 0, your thumb would be 90 degrees, and then this would be 30, 45, and 60. Okay, so for any of these, what you're going to do is put your finger down. So if you are being asked for 30 degrees, for instance, 30 degrees would be this finger. So you put that finger down, and then you count how many fingers you have either above or below. If you are looking for the sign, you count how many fingers you have below. There is 1 finger below, and the pattern goes like this. We have the square root of how many fingers divided by 2. Okay, so for the sign, we have 1 finger below, so it's the square root of 1 over 2. Square root of 1 is 1. 1 over 2 would be 1/2. Okay, let's do this one. Cosine of 45 degrees. 45 degrees, we said this was 30, 45, 60. So here's 45 degrees. For the cosine, you count up above. We have 2 fingers up above, so it's the square root of 2 over 2. So that's your answer. Then we figured out we needed to add the negative sign. Okay, so that works for either sine or cosine for any reference angle. Let's look at tangent. Tangent of 240. Reference angle would be right here. That is 60 degrees off of that x-axis. So then we find the tangent of 60 degrees. Okay, so here we go. We've got 30, 45, 60. So here's 60. Tangent is a little bit trickier. It's the y-coordinate divided by the x-coordinate. So the y-coordinate is root 3. The x-coordinate is root 1. So root 3 over root 1 would be root 3. And then adjust if necessary. In the third quadrant, tangent is actually positive because of this division. So we do not have to adjust the sign. All right, last little section here, we're going to move on and do some radians. So cosine of 11 pi over 6. Okay, if you need to, you can remind yourself of where exactly that is on the unit circle. 11 pi over 6. Let's fill some more of these out. So pi over 6, remember this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which reduces down to 2 over 3. 5 pi over 6, which does not reduce. This is 6 pi over 6, and 6 over 6 is 1. 7 pi over 6, 8 pi over 6, and 8 over 6 is 4/3. 9 pi over 6, 9 over 6. 10 pi over 6, 10 over 6 is 5/3, and 11 pi over 6. So that is that position. And then finally, we can do the quarter ones right here. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. So those are all of your radian measurements. So 11 pi over 6 is in this spot right here. The reference angle here would be 30, or pi over 6, if you want to use that. So the reference angle here would be 30 degrees, or pi over 6. So we find the trig function of that reference angle, so cosine of 30 degrees. So here's 30 degrees. Cosine counts up above. So we have the square root of 123 over 2. So root 3 over 2. This is in the fourth quadrant. Cosine is x. X is positive in the fourth quadrant. All right, and number 13, 4 pi over 3. If you need to while we're getting used to radians, always feel free to look at the unit circle to find it. So 4 pi over 3 is the same as 240. That is 60 degrees off of the x-axis. So your reference angle here is 60 degrees. Find the sine of 60 degrees. So 30, 45, 60 degrees. For sine, you count below. So that is root 3 over 2. In step 3, adjust the sign if needed. 4 pi over 3 was in the third quadrant. Sine is y. Y is negative in the third quadrant. And finally, number 15, 7 pi over 6. 7 pi over 6 is right here, also in the third quadrant, but this is 30 degrees off the x-axis. So that's our reference angle here is 30 degrees. So in less time, sine of 30 degrees. So here's 30 right here. Sine you count below, square root of 1 over 2, which is 1/2. And again, because we're in the third quadrant, sine is y. Y is negative in the third quadrant.